Hi guys, today we're going to be working with solving for exponents in grade 11. So this is the one video you're going to need in order to be able to do all of it. We're going to do every single thing you need to do for solving for x in exponents. We're going to start off with the basics, then we're going to move on to exercises, and the video is going to get more and more complex as we move on. And finally, we're going to do some really challenging level 4 questions. For those of you who want to get your 80s and 90s, it would be important for you guys to understand these concepts as well so you can get those marks. So this video is going to be divided into 6 sections. The first section, we're going to go over our exponent rules. Second, working with the prime bases and why do we even put our equations in prime bases. Then we're going to solve for x with the exponents. We're going to do some of those sums. Then we're going to solve for x with removing of a common factor. Then we're going to solve for x with the case substitution method, which is what you're doing now in grade 11, and also then the challenging level 4 questions. Okay, while working with these videos, I would recommend after you come and watch this video, you take a small break and then you try doing exercises that you may have at home. And if you have any more questions, leave a comment below. We can make a new video. Let's get into it. So looking at our exponent rules, our first exponent rule is that when we have a to the power x times a to the power y, we add. So when we have like bases, we add exponents. So that would look like if I had x to the power 2 times x to the power 3, I would then get x to the power 5. Or if I had y to the power, let's say, negative 2 times y to the 6, that will then equal y to the negative 2 plus 6, which then just gives me y to the 4. Understood? Now, if we take this into numbers, which is what we're going to be working with in this section, we're going to be applying the same principles. So let's look at a few with numbers. If I have 2 to the power x times 2 to the power x, I then get 2 to the power 2x. I hope you guys start seeing the idea. As long as the bases are the same. And what is the base? The base is this part right here of your exponent. You can see here, that is your base. The a in this scenario, the 2 in this scenario, those are your bases. Let's move on to the next rule. Now we're going to be working with our division. If I have a to the power x divided by a to the power y, I get a to the power x minus y. So for multiplication, since when we multiply like bases, we add the exponents. For division, we are going to subtract the exponents. So if I have x to the power 6 over x to the power 2, I would then get x to the power 6 minus 2, which would then give me x to the power 4. Working with actual numbers, if I had 2, let's say to the power 3, divided by 2 to the power, let's say 2. Let's look at this. This will allow us to see it a bit better. So here we'll get 8 over 4, which would then give us 2. And if we look at what happens when we work with these numbers, it's the same as saying 2 to the power 3 minus 1, which would then just equal 2 to the power 3 minus 2, which would then just equal 2 to the power 1, which is 2. So you can see it works. These rules work. I'm just going through it to show you so you can get them a bit more intuitively, or if you want to show up any of them, you get them now. Let's work when we have a power of power. I hope you have your calculators ready. So if I have 3 to the power 2 to the power 3, that will then give me 9 to the power 3, which equals 729. Now let's see what happens when we apply this rule. If I add 3 to the power 6, that then equals, put that into a calculator, 3 to the power 6, that also equals 729. So as you can see, this rule works. Let's just see a few examples of what happens when we put them with variables. So if I have x to the power 4 to the 3, that's just going to give me x to the 12. Okay, if I have 2 to the power x to the power 3, that's going to give me 2 to the 3x. It's also important to note that I can work forward and backwards when doing this. So I can convert 2 to the power 3x and look at it as 2 to the 3 to the x. You see that? Either or, depending on what you want to remove as a common factor. And that can then become 8 to the power x. These are all the same. Let's move on to if we have a fraction. So if I have x over y to the power 2, as you can see with our rule here, it will then become x squared over y squared. There's not much explanation into this. You're just applying the power to both of them. When working with this, anything to the power 0 is 1. So if I had a long term like this, x squared plus xy plus 2200 x to the power 0, it just equals 1. Anything to the power 0 is 1. And you don't have to show much working out for that. If you get a test or an exam, it is understood. Now, this is something new. This is when we have a division or a fraction in our exponent. So if I have x to the power 2 over 3, okay, this part right here where we have this 3 in the bottom, we're going to focus on that right now. If I have, let's say, 8 to the 1 over 3, if you put that into your calculator, you'll see it'll equal 2. And what's actually happening here is that we are saying the cube root of 8. So when you have a fraction as your exponent, what you're actually doing is you're applying the root. So for this question here, it'll then become like this. So your numerator, that becomes your numerator, and this is your denominator. Very important to note and understand. Memorize, understand, get this, because when it comes to the application, you're not understanding these principles, it's going to be very hard for you. We're now moving on. What happens when we have a negative exponent? When you have a negative exponent, what's occurring is it's going to swap from the denominator to the numerator. So if you look here, I have x to the power negative 1 over 1, and that's just going to swap. So this is going to come to this side to make the exponent positive. So I'm going to have 1 over x. Let's take another example. If I have x to the minus 2 over y to the minus 2, I will then write this as minus 2. I'll put the y squared on top to make it a positive. I will put the x squared on the bottom to make it a positive. Are you guys starting to get the idea here? So if I had 2 over x to the minus 2. That's just going to be, this 2 is going to stay here, to the x squared. Okay, so it's important you guys understand this principle. We are also going to be using it. And then finally, we're now going to solve for x with removing a common factor and the case substitution method. Okay, so with removing a common factor, what you need to understand is it's similar to when you are factorizing. So if I had x squared plus 2x equals 0, for example, I can see that there's an x here that is common, and I can remove that common factor, x into x plus 2 equals 0, and then I'll have x equal 0 or x equals negative 2. We're going to use that same kind of thinking. I hope you guys are realizing that when you're doing maths, a lot of the concepts are built on previous concepts. So when you're studying and you're having an issue with a certain concept, sometimes it may be good to just track back a grade back, a few terms back, and get that core understanding so you can then do the later on work. So when we're looking at this, we can take out 3 to the x as a common factor. We're working with this sum right here. We can take out 3 to the x as a common factor, and we're left with 4 plus 1 equals 15. 3 to the x into 5 equals 15. 3 to the x equals 3. And we're left with x equals 1. As simple as that. As long as you can see how to remove the common factor, you will be able to do the later steps. Let's move on to a slightly more challenging question. And here we're going to be working on this question right here. If we look, what can we see is our common factor, and it's 2 to the power x. But we have other things in our exponent. So let's rewrite it where they're just terms without any extra addition or subtraction in our exponent. So we'll have 2 to the x times 2 to the minus 2 plus 2 to 2 to the x minus 2 plus 2 to the x equals 84. Now, we then going to see that we have an x to the minus 2. So we're going to do the same thing for that as well. You can do this in one step. You don't even need to do the step if you're more familiar. But as you're learning, take it step by step and do these extra steps. Later on, you can start skipping some steps when your accuracy is high. It's more important to be accurate than save time. Though in matric, it is important to be able to do both. So practice, practice, practice. If you look at all these terms, right? So what I'm going to do is highlight each term. Let's get a nice highlighter here. See, this right here is one term. Oh, this highlighter is too dark. Let's use this light green. This right here is one term. This, let's pick another nice color. It's blue here. This right here is another term. And then this right here is another term. I want you guys to notice that when there is a multiplication, they count as one term. But once you have an addition and subtraction between the terms, the next term is starting. So note how to look when the next term is starting. So if we look at each of these terms, what is common? 2 to the power x. So I have 2 to the power x into 4 plus, there's a plus sign here, plus 1 over 4, which is the same as 2 to the minus 2, plus 1 equals 84. And then if we look here, this will be 2 to the x into, you put this into your calculator. So we'll go 4 plus 1 over 4 plus 1, and that will give us 21 over 4 is equal to 84. We times in 2 to the power x by 21 over 4, so we're going to divide 84 by 21 over 4. So we're going to go into our calculator. First, let's write down 2 to the power x equals, and then we're going to go 84 divided by this 21 over 4, we'll get 16. Then we can go equals, we'll press shift fact into our calculator. So we'll have 16 shift fact, and we'll get 2 to the power 4. So we have 2 to the x equals 2 to the power 4, and then we have x equals 4. Like bases, we can drop the exponents. Going to look at E. Now, in E, there's something that's different, and that's that this x right here, okay, it has a 2 in front of it. If you look at our other questions, here and here and here and here, the x has a coefficient of 1. There's a 1 in front of it. So when there's a 2 in front of it, or when there's not 1, we're going to use the k substitution method. And when working in the method, the criteria is that this coefficient here is double the next coefficient. So let's go into this question. We're going to do the same process as the last one, where we separate the terms first. So we have 3 to the 2x minus 2 times 3 to the 2 times 3 to the x plus 81 equals 0. Now let's simplify this a bit more. So I'll have 3 to the 2x minus 9 times 2, which is 18 times 3 to the x plus 81 equals 0. Okay, so let's go into this. This is a new technique that you're going to do. You're going to let the term that is half, you can see this x here, this part of this term, that is half this right here. It's half the exponent component of it. So the one that is half, we're going to let it be k. So we're going to say let 3 to the x equal k. So now I'm going to have k squared. Now you may be asking, how did I get this k squared? Because if I have k squared, it actually equals this 3 to the x to the power 2. We're doing it like that. And since this right here is k, we're putting it in there. So now, since we understand that, we can say minus 18k plus 81 equals 0. We now can factorize this, and we'll have, so when I do my factorization, I like to put the brackets first. I put k here, I put k here, then I say, okay, 9 and 9, it's going to be a minus and a minus, so then k equals 9. Okay, we got this, we're done. No, we're not done. The question is not to solve for k. The question is to solve for x. So I'm going to substitute what we let k be back in here. So I'm going to have 3 to the x equals 9. And now I'm going to have 3 to the x equals 3 squared, and then x equals 2. Let's move on to the next question. We're now going to do g. And in g, we have this 4x and this 2x. So what my first instinct here is, let me convert this 4. And this 4 can be written as 2 to the 2 to the x plus 4 times 2 to the x minus 5 equals 0. Now, this isn't a term we can work with. Before, it wasn't in a way we could work with it. Let me write this x a bit neater. So now it is in a way we can work with it. So we'll have 2 to the 2x plus 4 times 2 to the x minus 5 equals 0. And now since we have this middle term that's half the first term, we can say let 2 to the x equal k. And in doing so, this is now going to change to k squared plus 4k minus 5 equals 0. I'm going to open my brackets, equal 0. I'm going to have 5. I'm going to have 1. I'm going to have k, and k, what's this? Plus 5 minus 1. I'm going to have k equals 1, or k equals negative 5. Now for the k equals 1, we're going to say 2 to the power x equals 1. We know that 1 is the same as 2 to the power 0, so we know that x equals 0. For this k equals negative 5, we're going to have no solution. Now you may be wondering, why is this no solution? And let's look at this for a second. If I have 2 to the power x equals negative 5, is there any number that I can put to this positive number as a power to get negative 5? No, there isn't. Because if I put 2 to a negative, let's say 1, it only becomes a fraction. It doesn't change it from a positive to a negative. If I put 2 to a positive number, I'm just going to get a bigger positive number, so it doesn't work. If I were to put a fraction, so let's say I put 2 to the half, I am just going to get the square root of 2, which isn't going to give me a negative number. So there's no real solution here. Let's move on to some challenges. We're now going to move on to some challenges, and these are proving questions. So when you're dealing with proving questions, you're going to deal with one side of the equation. So in these, I always like dealing with the side where you're going to simplify, not expand. And on the left hand side for both these equations, we're going to simplify. So we're going to say the left hand side equals, okay, now this root 3 can be written as 3 to the power a half. Yeah, then we have minus 2x plus, now you can see here that our main base that we are dealing with is this 3. So we're dealing with this question is this 3. So And in our answer, we have a 3 to the power x. So when we're working with this, we want to isolate this 3. So we're going to have 4 times 3 times 3 to the minus x, right? And then this, a power of power, we multiply them. So I'm going to have 3 to the minus x. I had that because I went negative 2x times a half. I'm going to have plus 12 times 3 to the minus x. Now this might look familiar to you guys, and it should, because we now have a common term that we can remove as a common factor. 3 to the minus x into 1 plus 13, 12. And then we'll get this. So when we're dealing with this, we have a negative exponent. If you look at what we're proving towards, it has a positive exponent. So we're going to bring this to the bottom, and we have 3 to the x, and we have 1 plus 12 is 13. If we look at our question, is there more we need to do? No. So we then just say, therefore, left hand side equals our right hand side. We're going to work on number 2. Again, we're going to work with our left hand side because our left hand side is a side to simplify. So we have 9 to the power x plus 1 minus 6 times 3 to the 2x, root 3, 4 to the x, 4x plus 1 equals root 3. If you look here again, 3 is our main base we are working with. So let's convert whatever we can to that base of 3. So I'll have 3 to the power 2, and that's going into x plus 1 minus 6. This is already in that main base, over, now this root 3 can be written as 3 to the half plus 1. Go further, an exponent of an exponent we multiply, so I'll have 3 to the 2x times 3 to the 1 minus 6 times 3 to the 2x over, oh, I didn't finish writing this term over here. This term here is 3 to the half 4x plus 1. So I left out the 4x here. Then I'll have 3 to the 2x, because an exponent of exponent, so I'm going to multiply this half by the 4x, and I get 2x times 3 to the half, which is that 1 times a half. Now, as I move on, if you look at the top part of my equation, I have a common factor of 3 to the 2x, and that's going to go into 3 minus 6. Is that correct? Is that correct? Yes, that is correct. And yeah, I'm going to have this 3 to the 2x. Let me just make sure I looked at my question properly. Minus. Oh yes, here's my mistake here. This should be squared. Because if we look above, it will be 3 squared into both of them. This is the danger of skipping steps, guys. So this will be 9 minus 3. I then continue, and I'll have times 3 to a half, and this term right here cancels off with this term right here, and I'm left with 3 over 3 to the half, which is the same as saying 3 times 3 to negative a half, and that's just going to equal 3 to the half, which is equal to the square root of 3. Hope you guys understand that. I did make a silly error, but when you're doing your maths work, sometimes you're going to make errors, and that's why I leave them in the videos to show you guys it's okay. Just make sure you double check your work. Third one now. And when looking at this third question, you see that there's this restriction section here where x is greater than 0. And the reason why they're saying that is, in our terms that we have x to the power 5, if we had a negative there, we get a square root of a negative. So don't get intimidated by these restrictions. Sometimes even if you don't understand them, just apply your work. So let's say I didn't understand this restriction. I just looked at it, it confused me, but I still want to get the marks. What did I do? Again, I'm going to work with the left hand side. And for my left hand side, since I have a square there, I'm going to put down my denominator first because that's the easy part to work with. Okay, now I'm going to square this, which means first, before I do that, I'd like to convert this into a 5 over 2 minus x to the 3 over 2, and this is all squared. So if I were to rewrite that, it'll be x to the 5 over 2 minus x to the 3 over 2 into x to the 5 over 2 minus x to the 3 over 2 over my x squared. Now I'm going to have this term here times this term times this term, and then that term. I'm just going to FOIL. So I'll have x to the 5 over 2 times x to the 5 over 2. So x to the 5 over 2 times x to the 5 over 2. I'm going to add that, and that's going to give me x to the 10 over 2, which will just give me x to the 5. And the same process is going to happen for the rest of the multiplication. So I'm just going to go through it now. And I'll have x to the 5 minus x to the 8 over 2 minus x to the 8 over 2 plus x to the 3 all over my x squared. That's now going to give me x to the 5 minus 2 x to the 8 over 2 plus x to the 3 over x squared. I'm then going to get x to the 5 minus 2x to the 4 plus x to the 3 over this x squared. and here I'm then going to get a common factor which I can remove, and that common factor is x squared into x to the 3 minus 2x to the 2 plus x over x squared, and I can cancel these out. Let's do our cancelling out in blue. And now the terms I am left with, I can remove another common factor of x, which I'll then get x squared minus 2x plus 1. And if I was to factorize this, I'll get x into x plus 1 squared. And right here, what I have is the answer, because my left-hand side equals my right-hand side. So when you're dealing with questions like this, it's good to see that you don't have to see the answer immediately. Just work step by step by step. I hope this video is helpful. If you guys have any questions, please leave a comment down below how I can make the video better. If you want me to do more examples, I can. Please leave a like and subscribe.